those two problems. I think there's a problem in between the two of them. But chat with your team about if you look at rectangles A and B, are they similar? And don't just like gut react, like, oh yeah, they look the same. Like mathematically prove, like make a mathematical argument about are they similar.
Yes.
You can't just say yes. We gotta defend it.
6 to 4 are the one that's sure.
We're on 16. We're on 16. A hot second. I gave this out at the end of class yesterday, but you guys, we're on 6.2.4. 6.2.4. Do you not have this? Yeah, you probably started wrong. Oh, there it is, right there. Yeah, I see it. That's it. All right. Find your, I'm trying to think of a keyword that means like disaster, but hey, you should turn that in. 624, anyone else need it? 624, all good? What dudes? 624, we all good? Ooh. I love the argument that I just heard. I was about to pull out random cards, but hold on. Suck us all into your conversation. What are you guys talking about?
So, Colin said that A is a fourth of B because it fits into A 4 times, but I said no, it's half of B because the sides were split in half. Yeah, it's half of. Wait, this is fourth.
You're both right.
It's the perimeter and area. Like if you multiply it by 2, then you'll get. Oh!
You multiply both sides by 2.
Yeah, because like I'm right.
Then you have to rotate it. Colin, then you can rotate it. Colin, then you can rotate it.
You're both right.
You're both right.
Yeah, like Mr. Hudson. Like I'm right with the perimeter, but he's right with the area.
Drop the mic.
That's a 10.
Hey, come on. Max just gave us a huge thing that matters with scale factor. Go ahead. Yeah.
Oh, okay.
Oh, okay. Like, do you not want to sharpen your pencil?
I want to be closer.
When we compare the two shapes, and we compare the side of 2, come on, the side of 2 to the side of 4, and the side of 4 to the side of 8, we see that the scale factor, come on, is in fact times 2, right? We multiply everything by 2. But when we apply a scale factor to the lengths, the original area would have been, oh my gosh, smart. All right, we're going to try to fix this. I think I know what is going on. Guys, I get that that's funny, but for me being a teacher and trying to promote things, when tech isn't working, you can't just like make fun of it. You got to figure out what's going on. So be a problem solver, right? Be a problem solver. The area is length times width. And when I scale my shape up, the new area is double the length, double the width, double your pleasure, double your fun, double whatever gum that was. What happens when you double?
4.
You quadruple. So, here's the thing though. What we are often talking about is what is the scale factor, because we're trying to draw things. But then, the area comparison is not the same. So here's a question for you. What happens when the scale factor is 3? So you got hands, right? I will do random cards, but I will take a hand if someone wants to volunteer to try to answer this. When we scale by 3, Patrick, what do you think happens to the area?
It multiplies by 6.
No. Jordan? It multiplies by 9. So guys, the impact on area, you don't even have to learn this yet, but teachable moments are teachable moments, and you gotta take it. The area impact is the scale factor squared. Because area squares lengths. So the area will square what we did to the length.
I'm as puzzled as we are as how you name connections.
Good, because that's when you're learning. Confusion is the beginning of learning. So we talked about this yesterday. What scale factor will not only not change the area, not change the perimeter, but won't change anything at all? Anybody?
1.
1.
0. Oh, never.
What would a scale factor of 0 do?
0.
Ooh, it would destroy the whole thing. Yeah.
Obliterate it.
What?
Obliterate it.
Obliterate it?
Yes.
I think you've made up a word.
No.
We shall move on.
It's
Is
a
this
Harry
one on your
Potter word.
paper?
It's a Harry Potter word.
I know it's on your paper, but I'm asking to make you look at your paper. Follow Angelina's directions. And then we will start over and follow these directions. So each of them are starting with shape A. So, sorry, I'll try to make this as big as possible. You have shape A on your paper, but you don't have the directions on your paper because I could not fit them. I tried. I am sorry that I could not fit them. Trust me, I try to make your life easier. So first things first, reflect the triangle across the x-axis. 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 Remember, the x-axis is it the horizontal or the vertical?
Vertical.
Whoa, that was some different answers. Guys, it's labeled. Your axes are labeled. Hold on, the x-axis is this axis, guys. This is why we're practicing this. So if I'm reflecting across the x-axis, should I be going to the right or going down?
Down.
We're flipping it down. Yes.
I still don't understand the first one. You moved on before.
So the sequence of transformations I'm not as worried about as talking about the scale factor is 2, and therefore we know they're similar, because when I count, this is 8, this is 4, this is 4, that's 2. There's actually a bunch of different options here, so that's why there's no right answer, actually. There's a bunch of right answers, but there's not one right answer. You can circle back around and talk about the solutions that get us there, because this problem will help you with that. So first things first, we're going to reflect A across the x-axis, or over the x-axis. Yeah, so down to there.
How do you do that?
How do you do what? Oh, for rotation? I'll show it up here. Alright, so A prime, our first modified A, would be, since A was 1 up, it'll be 1 down. That was 1 up, it'll be 1 down. This was 1, 2, 3, 4 up, it'll be 1, 2, 3, 4 down. If you want to try to be funny like me, you could write your A upside down if you want. Ooh, nice. See, you are my people. 12 and 13-year-olds are the people that, like, get me. Then I hang out with adults, and they're like, bro.
Was your man-child?
I mean, I didn't use those words, but if you want to
I know someone's
make it
man-child.
weird like that.
I know someone's
So,
man-child.
Max asked me to remind everyone about the hockey stick method, which I will admit I stole from Mr. Hall, 100%. I've never really played hockey. I've played street hockey, but I've never played ice hockey. The hockey stick method is draw a hockey stick so then you can rotate the hockey stick. It doesn't matter how you draw it, but for example, if I draw my hockey stick to the point at like the top of the triangle, it's 2, 4. If I rotate that counterclockwise, I'm still going to go 2, 4, but rotated counterclockwise. So you don't have to draw it if you can visualize it. I'll make this green since I started making green. So then my next hockey stick is 5, 1. So then I want to go 5, 1, rotated, right? So this hockey stick would be 5 over, 1 down. So I'm going to go 5 down, 1 over. Then 1, 1. So I go 1, 1 again.
Oh my god.
Questions on how we got here. And they say about the origin, so that's why we're using hockey stick from the origin. Guys, I make mistakes, so if I mess up, you gotta tell me.
You made a mistake. Oh, no, you didn't.
Hey, Jake, it's not funny. Because we're all trying to get through this and then do the work that we're supposed to do. So if I actually make a mistake, tell me.
Okay.
But we're not just trying to turn it into a joke.
I made a mistake.
There we go. You don't need to announce to the class, but there we go. And then... Wait.
Yes. So, if, since it's 90 degrees, it would just be going to the next quadrant, and 180 would be going to the directly across quadrant?
Yep. 270 would be 3 quadrants around. 360 would get you all the way back to the beginning.
Okay, thank you.
Tony Hawk was the first person to land a 900 on a skateboard, and none of you were alive.
Wait, what's that? How do you land a 900
The
on
fact that you don't even know who Tony Hawk is.
I know who he is.
How do you do a 900? Or a 90?
Well, 360 degrees. What's another 360? 7. Do math. 360 plus
wait.
720, and then another halfway around. So he went up in the air and went once, twice, and another half, and came back down. Yeah.
That's impressive.
But
On
now
a
people do even more than that, because like skateboards go faster, ramps are built differently. Like now, math has helped athletes be able to do even more than that. But yeah, Tony Hawk was the first person to land a 900. Speaking of angle degree rotation, thank you. We've decided that algebra tiles are like glitter. So if you see algebra tiles on the floor, we're using them in Math 7. Please help me pick them up so the vacuum doesn't get them. Grant.
Has anyone done a 1,000?
A 1080? Yeah, I think it's been landed now. The weird thing is then you're landing goofy because you're landing going the reverse way you normally skate. So if I go up a ramp this way and do a 900, I'm coming down the ramp, still leading with my left foot. If you do a 1080, I went up this way and I'm coming down this way. Right? So it's I gotta ride backwards.
Like you need another ramp on the other side.
And actually, they've done that with a mega ramp. Actually, if we get through this, I'll show you guys. One of the young, she's like 12. One of the Olympic skateboarders, and I say young, not like younger than you, but like young for Olympics, was hanging out with Tony Hawk and went off the mega ramp. Oh, thank you. The cup, the glitter cup is over here. Or it's big, yes, okay, thank you. Most people don't like walk up to the bags, they just bring them to me. Then dilate! Am I good to then? Can we move on from talking skateboarding?
Yeah. No.
As long as you're talking about the triangles, not skateboarding.
Oh, well, this is skateboarding, but like, wasn't like the youngest person in the Olympics this year like 12 in like the?
They had a youth, yeah, they had a youth Olympics. Like, it's still the Olympics, but they had a youth level. Like, so under 18. So, 1/2. Here's the issue. Some of you might have shrank down the triangle inside of A. Not quite. Remember those lines that come from the origin? So dilate the figure by a scale factor of 1/2. So my 1, 1, well 1, -1 really, goes here to 1, -1/2. Right, my 4, -2 goes to 2, -1. And my 1, -5 goes to half, -2.5.
Well, this is gonna be cool. It's gonna be another 3D.
Yeah, it's gonna be another one of those like kind of makes a tunnel sort of thing, right?
I like tunnels.
Well, I'm teaching a Friday Creative Option Math Art class that you can sign up for next week.
Shameless plug.
Yeah,
Yes.
What is this for today's Friday class?
Door decorating and or get mastered.
Oh, okay, look.
Some of you, Mrs. Goldring said she's gonna plug in the spanking machine for kids that aren't mastered. Go take a turn on the spanking machine. It's a joke. I'm not sure. All right, do we have questions on what Angelina did?
Yes. Oh, wait, no. I
Try. I'm gonna walk around the room, so if you have any questions, want me to look at your paper. Try what V did, starting at original A. Okay, start back at original A. Here's what V did.
Should be the same.
Now you can leave that.
About its top vertex.
About means around.
Okay.
Yeah, about means like do it around, like pivot from that point.
Dang it, that's annoying.
Okay. So start at original A, and the first thing it says is translate the triangle 4 units right, 3 units down. Okay, then rotate the triangle clockwise 180. Ooh, there's 180. About its top vertex. If I'm going halfway around the rotation.
Yeah, but where would I start?
What do you mean where? I'm confused with what you mean where.
Like instead of
The new shape that you just moved. We're gonna take that and pivot it 180 degrees.
Okay.
And the funny thing about a 180, it doesn't matter what direction we go, because whether I turn this way or whether I turn this way, I'm still gonna be pointing that way.
Oh, wait.
So
Wait a minute. Oh, wait.
about its top
My
vertex.
graphic looks really weird. My graph looks really weird.
That'd be awesome.
What was her name?
Wait, just gotta rotate it around. So,
Oh.
clockwise, counterclockwise, or clockwise.
This is getting like really messy with all these. There's like I have a million of these on triangles on there, and they're like all smushed together. Like
Yeah, I have the same. Like my
So,
A is squished.
maybe you guys might start to believe me that after winter break, we need to bring highlighters,
Color pencil.
shameless plug, or colored pencils.
I just borrowed one.
Alright, I can't plug it, I'm not.
pause for YouTube.
Same place as 180 degrees, right? Because 900 has 180 degrees extra, right? There's 180 degrees extra of rotation. So when we rotate this triangle counterclockwise, and yeah, I know we got triangles on triangles on triangles, but I'm going to erase this because I should have put 2 of these on your paper. My bad. Next year I'll change it. So we moved it over.
Hey, don't read it for the other kids.
1, 2, 3, 4. Well, you guys might have to help me so I don't have to keep scrolling. 4 and 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. Oh, and this is on your homework. We would write this X.
1/2.
Ooh, how do we write moving the triangle right 4 units and up down 3?
That's something else.
X plus 4.
Y plus 3.
Y
Minus.
minus 3, or you could say plus negative 3. Yeah, I do think it's wrong. I've got a lot of hands up.
Oh, bottom points up.
It is too high. This needs to be there.
Yeah.
Thank you. I do make mistakes.
Where did this go?
It's
right there.
Yeah,
Yeah.
okay. So then, we rotate 180. We could still hockey stick this, but if you're going to hockey stick this, we're from this as our center of rotation. So if I go down 3, right 1, up 3, left 1, right? That would be the rotated hockey stick 180 degrees. Then 3, 3. So 3, 3. Good. You approve.
I approve
And
this.
then, I gotta leave that, I guess. So then we are here.
I hate those. I don't approve.
And then
Approve, you said.
reflect the triangle across the. Ooh, x equals 3.
Yeah, I was confused.
No, wait. I think I know you.
Can anyone tell me about the line x equals 3? Renal?
It's when y is always, it's like the x is always 3, so it's like y is 1, then x is 3, then y is 2, it's always 3.
When, say what you just said again.
When y is 1, x is 3.
When y is 1, x is 3, x is 3. You said so y, even as y changes, x is 3. Oh. It's a vertical line. Thank you, Renal. No matter what y is, x is 3. Guys, conversely, if y was 3, it'd be a horizontal line at y equals 3, but an x equals line is vertical. So then, if we reflect this across... Wait a minute. 1, 2, 1, 2. Won't these points just swap? Like this point swaps to over here, and this point swaps to over here, and then this is the only point that really like changes. I mean, they all change, but so now our new triangle should be here. And yeah, it still fits on our graph, but we got triangles on triangles on triangles.
It looks like the triangles are folding down top of each other.
Yeah. Questions? Who what? That's okay. Guys, something that us teachers have been talking about is trying to get you guys more comfortable with when things don't go right. It's okay when we make mistakes. It's okay when things don't go as planned. It's okay when somebody tells you you did that wrong.
No, it's not.
No, it is. Like, I know you're kind of joking, but I also know that you're not joking. And I need you to hear me when I say, as math gets harder, you won't get it all right. And that's fine. Oh, you can't see it. The poster that's normally on my door is a quote from Einstein that I love. I will keep that poster alive somehow for my entire teaching career, or I'll buy a new one. The quote is, no matter what your difficulties are in mathematics, I can assure you mine are far greater. Math doesn't get any easier. It only gets harder. You just have to get more determined. Wrong answers are going to happen. It's okay to not know exactly what we're doing right now. We're progressing towards mastery. Just like, this is a great segue because I kind of wanted to show this anyways. Sure, Friday full of videos. Like, real story, real talk. I wrecked my car in high school. I was swerving to miss a deer. I'm from deer country. Wrecked my car. Did I stop driving? No. Guess what I kind of got more into? How to fix cars. That's what you get motivated, right? You're like, well, I messed this up. Time to fix it.
Power of courage.
Max?
My brother crashed.
Max? Sorry. I'll take you too, Lily, but Max raised their hand.
But when I used to skate, I would be like terrified of even just going on like a tiny little like. I'd just be like terrified of everything.
This scar was when I was on flat ground. Flat ground. And I just rock. I hit a rock. My arm just went into like a wall. It was bad. We're out of time, so have a wonderful weekend. Good hanging out with you guys today.
Basically describe the story of how to ride a bike.
Yeah, right?